A little trigonometry, a little SOHCAHTOA. Alright, so what we're doing today here is SOHCAHTOA. This is, by the way, the answer to number 1. If you didn't, if you left it blank, like Kason, he's going to be leaving that blank. Alright, right triangle ABC with right angle C. So what matters here is angle C. She's right there. And we'll just do ABC, go around like a clock. Hypotenuse is A to B. We have leg segment AC. And I guess the first thing I need to do is I need to figure out the missing side length. So I do a little bit of Pythagorean theorem. A squared plus B squared is C squared. If you're that dunce who doesn't know, these are the legs. And this is my hypotenuse. So the right hand side is 7 squared, left hand side is 4 squared. So 4 squared plus B squared is 7 squared. And we just do the math. I mean, if you got to be a button pusher, be a button pusher, whatever. But B squared is going to be 7 squared minus 4 squared, because we're going to play the isolation game. And this is going to be 49. 49 minus 16 ought to be 33. So B is the square root of 33, and I'm not going to round to a decimal. There's no need to. Alright, now we're supposed to find all 6 trig ratios for angle A. So the angle of interest here is angle A, and I'm going to find all 6 trig ratios. All of them. I'm going to find the sine of angle A. I'm going to find the cosine of angle A, the tangent of angle A. Now, from SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, in addition to those 3, I'm going to find the reciprocals. It says all 6. So, in addition to those 3, I also need their reciprocals. And the reciprocals are cosecant. Sine says O, cosecant is a hoe. The reciprocal of cosine is called secant. And secant says, cosine is a breath of fresh air, secant is the funny guy. And the reciprocal of tangent is called cotangent. And it says AO because we flip O over A. Alright, so I'll do the first 3 and then I'll flip them. That's all I'll have to do. So the sine of A is going to be root 33 over 7. Easy peasy. The cosine of A, and I forgot to mention something, this is adjacent, this is opposite, and this is obviously the hypotenuse. The cosine is adjacent over hypotenuse, so 4 over 7. And finally we have opposite over adjacent, root 33 over 4. Those are pretty simple. We're going to do some more work on the reciprocals, because when I do cosecant, when I flip this, I get 7 over root 33. So I go through the cleanup process. I multiply the top and bottom by a root of 33, and I get 7 roots of 33 over a 33. That's all there is to it. Secant's easy. You flip 4 sevenths, you get 7 quarters. And there'll be work to do on this one too, because when I flip this one, I'll have 4 over root 33. And I just go through the cleanup process. Make this thing. It's called rationalizing the denominator. So this is 4 root 33 over 33. Not a hard problem. It's really not. Make of it as you will. Alright, given the sine of theta is 2/5, find all remaining trig ratios you'll need to draw. It's just like the one I just did. There's nothing special about it. Whoops. Something happened there, didn't it? Now, theta, I always put it in the lower left-hand corner. So here's theta. I am told that the sine of theta is 2/5. And I know that the sine ratio is opposite over hypotenuse. So opposite of theta is a 2, and the hypotenuse is 5. Now, by the way, if I have the sine of theta, I also have the cosecant of theta. Because cosecant is a whole, so it'd be 5/2. Let's do a little Pythagorean theorem here. I have no idea what this length is. I'll call it A. A squared plus 2 squared is 5 squared. So A squared is going to be 25 minus 4, which is 21. So A is the square root of 21, which does not simplify. Now I'm in place to do the rest of this work here. So let's do cosine. Cosine is adjacent over hypotenuse. So I'd be looking at root 21 over 5. The reciprocal of cosine is called secant. It's the reciprocal. Flip it. 5 over root 21. Multiply numerator and denominator by root 21, and you get 5 roots of 21 over 21. Next we have the tangent ratio. Tangent is opposite over adjacent. So 2 over root 21. Clean it up. Multiply by root 21 over root 21, and I will get 2 roots of 21 over 21. And then we have cotangent. Cotangent is AO. Adjacent is root 21. Opposite is 2. These are really simple problems. So get it. Get something this year. Alright, number 10, given that the cosecant of theta is x, find the tangent of theta and draw. There's a way to do this without drawing, but you have to memorize quite a bit of stuff. Now, I know that anything in this world is divisible by 1. Everything in this world is divisible by 1. It's called manipulation. I also know that the cosecant ratio is a whole. So I'm going to put theta again in this corner. The hypotenuse has to be x, and the opposite length has to be 1. I'm going to do some Pythagorean theorem. Find this missing leg. A squared plus 1 squared is x squared. A squared is x squared minus 1, because 1 squared is still 1. And A is simply the square root of x squared minus 1. Do not think you can do anything with that, because you cannot. Now I am tasked with finding the tangent of theta. The tangent of theta would be opposite over adjacent. So if I'm here, opposite is a 1, and the adjacent length is this. Now sometimes trig people clean up. The rule about rationalizing the denominator is really just meant for numbers, okay? It's not really meant for expressions of x, but sometimes people do it. So let's take our 1 over x squared minus 1 and multiply it by the square root of x squared minus 1. Same thing we would do if it was a number. And I would get square root of x squared minus 1 up top, and down low I would have a radical times itself as the quantity inside, x squared minus 1. And one more. A 300-foot cell tower has guy wires attached 10 feet from the top that form a 56-degree angle with the horizon. How long are the guy wires? So cell towers usually stand straight up. And 10 feet from the top is where these guy wires attach. Usually there's 3, they're 120 degrees spaced apart or whatever. Now if 10 foot's been accounted for, there's 290 foot left to get to the ground. Just drawing this imaginary third side here. Tower stands straight out of the ground. And I form a 56-degree angle with the horizon, which is actually here. This is the horizon. Now, because of a theorem called alternate interior angles, and the fact that the ground is more or less parallel with the horizon, if there's a 56-degree angle here, there's a 56-degree angle here. Angles of elevation are the same as angles of depression, which is what that angle is, are the same as angles of elevation because of alternate interior angles. Anyways, how long are the guy wires? So I want to know what this is, right? That's the question. Well, 290 happens to be an opposite length, and this unknown happens to be a hypotenuse. So I just do a little basic trig. The sine of 56 degrees must equal 290 over x. And then congratulations, you're in Algebra 1. We multiply both sides by x. X sines of 56 degrees is going to be 290. And then we counteract this understood multiplication with division. So x is going to be 290 sitting pretty over the sin of 56 degrees. And then we go push buttons. Now notice that's a degree symbol. So I go to mode and make sure. 290 divided by the sin of 56 is 349.80. And there you go. There's your homework from 13.1. Hope you enjoyed it. Of the 5 or 6 of you that are actually going to do it,